The idea of RAID is a fairly simple idea when you think about the name, a redundant array of independent disks. So in other words, the idea is I've got several disks, independent disks, and I make an array out of them, a redundant array. In other words, I can take several disks and make them look like one disk. However, there are various types of RAID, and I use them for various purposes. Now, we're only going to look here at a few of the basic ones and a few of the basic ways that we can use them. So there are a couple of ways that we can put them together. First of all, realize that there are different ways that we can accomplish RAID. We can accomplish them by hardware. In other words, RAID can be built into the BIOS or the UEFI of the machine and actually be controlled by a RAID controller on the motherboard. This is actually the best way, the fastest way, because it doesn't require the CPU and other software to be running in the background, which would slow things down because then the computer has to be doing extra computing in order to do it. It's done by the hardware in the background. Or we can do it by software, and if we use software, of course, it overcomes the problem if we don't have hardware RAID built into our computer. But again, it slows things down a little bit. So you get better performance with hardware RAID. Now, the idea of RAID is that we have to understand the kinds of volumes that are put together or that we can have on our systems. And let's take a look here at my device or my disk manager. Maybe a moment for it to come up. Here we go. Notice that we have some terminology here. Each of these partitions, and let's take this disk 2 as an example because that one has 3 different partitions on it. Notice that disk 2, that's this C drive one, that's this, and this. These 3 top entries up here are the 3 partitions on disk 2. There's a C drive partition, and then there's a partition 1 and a partition 4. Now, there is something called the simple layout and the basic type on these 3 partitions. Now, what throws you off here is this term basic actually refers to the entire drive. Even though it's listed on each partition, this is actually telling you that this is partitioned as a basic drive. And by being a basic drive, it's telling you that the partitioning type on this entire hard drive here can only allow for partitioning on this drive. In other words, I can't span this drive. I can't make a RAID drive out of this drive because it's a basic drive. So if I wanted to make a RAID drive, I would have to turn this basic drive, and notice it says basic over here, even though it's listed as basic under each partition. I don't think of it as each partition being basic. It's the entire drive that's basic. I would have to change this to dynamic, convert to dynamic disk. Once I convert this and another one to dynamic, then I can span these to partition into spanned partitions that would span multiple drives. Then I could make a RAID drive out of it. Now over here you see this simple layout. Now the simple layout does refer to individual partitions. In this case, this is the simple layout just refers to a single partition which could span, if this were a dynamic disk rather than a basic disk, and by the way, if I did change these, the word basic would change to the word dynamic, and a single partition would still be called simple, but a simple partition could span multiple drives. But simple is not the only kind of partition. There are also other kinds of partitions that could be made, and there is one that is called spanned partition that is designed to be spanned across multiple drives. So we can have a simple volume, a spanned volume, and a RAID volume. Now, one thing that is not mentioned here is something called striping. Now, striping is the way that RAID 0 works, but it's not mentioned here in RAID 0 volumes. However, let's go down here to this slide, and you'll see that a RAID 0 volume, what it does is writes a file 1A, file 1B, file 2A, file 2B, file 2C, file 2D. So what it's doing is it's writing part of the file to one drive and then part of the file to another drive, and then part of the file to this drive, part of the file to this drive. Now, why would it do that? Well, because it can write to both drives at the same time, and it makes reading and writing to the drives very fast. It doubles the rate at which I can read and write to the drive by writing to two drives at the same time. Now, the problem is that if either one of these drives goes bad on me, I lose everything. Right? So the purpose of a RAID 0 is to be able to take two drives and double the speed at which I can read and write to that drive. Now, a RAID 1 volume, let's go back up here to our RAID 1 volume is called mirrored volume. And the idea of that is to take two drives, and I'm going to write everything to disk 1, and I'm going to mirror that to a disk 2, so that I have two copies of it. Now, the idea here is if I lose one drive, I have another drive that also has all of that information. So I have redundancy of my information here. Now, this is not a backup. Don't think of it as a backup. In fact, it's a poor substitute for a backup, because backup should be on a separate machine, and in fact should be on a separate site altogether. However, it does provide some redundancy. And if I lose one drive, if one drive fails, I still have that data on another drive. So RAID 1 provides that redundancy. There are some other RAIDs between here, but we're not going to look at those in this course. We are going to jump down, however, to RAID 5. RAID 5 is probably the most common. However, RAID 5 requires 3 disks. So with RAID 5, here's what I do. I stripe just like I do in RAID 0. However, I also add some extra information, some calculated information called parity. And parity is some mathematical magic that allows me to reconstruct data if I lose a drive. So the idea of RAID 5 is that if any of these drives goes bad, I can pull that drive out and put a fresh drive in, and the other two drives will reconstruct the missing data, and I can just continue. So I'm getting the benefits of RAID 0. In other words, I'm getting that fast read and write speed of RAID 0, and I'm also getting the benefit of RAID 1 in that I'm getting that redundancy so that if I lose a drive, I don't lose the data. So it's like RAID 0 and RAID 1. I'm getting the benefits of both of them with RAID 5. However, it does require 3 disks in order to do it. So those are the 3 most common versions of RAID. Now, it's worth mentioning here, even though it's not on our slides, that RAID is an older technology. It's still used very, very much, but with Windows 11 today, we also have something called storage spaces, and with storage spaces, you can do something like RAID by combining your disks into one big disk and then portioning out portions for various volumes. And so storage spaces is all done. I did this, I know I showed this in another video. If I go to settings and type storage spaces, these 2 areas in the settings area is where I would set up storage spaces. It's much easier to set it up here than it is to set up RAID. So you can set that up. In fact, it'd be fun to play with it. If you have a couple of extra drives, you can mess around with storage spaces. With servers, there's also something called Storage Spaces Direct. Storage Spaces Direct is nice in that the spaces don't have to be on the same computer. They can be from a whole bunch of disks. We call them JBOD, or just a bunch of disks. And they can be mismatched disks, and they can be different types of disks. You can have solid state disks and magnetic disks and all sorts of storage, and just put them all together and use them make them into one big pool, and then portion out what you want to various computers, and it looks to each computer like it owns each particular drive that you portion out to it, and that's called storage spaces direct. However, on Windows 11 you can do storage spaces, not storage spaces direct. So that is kind of a cool technology that Microsoft has given us to replace RAID.